are having all this different data set of Copernicus spread across different services to bring it into one platform. We started with the Sentinel missions. So all the data set are already here. For Copernicus services, we already have onboarded CAMS dataset and others are CLIMS dataset, sorry, and others are in the process of onboarding. So you will find all these different data set in this single platform. And in order to access it, all you can do is, I will also paste all this link in Mattermost, but you can play around while I do it over here. And I'm trying to act a bit brave to run each of myself today here while sitting with you so that you can also follow with me and run it. And also if you encounter issue, then we can tackle it together. That's the idea. Otherwise, I do have a backup. Hopefully it will run and we all will be able to run it together. That's the idea. But the first page that you can land on is this dataspace.copernicus.eu, or you can easily search in Google Dataspace Copernicus. So this URL should pop up at the top. And this is the landing page which describes what are the different services that it has to offer. In the data section, it will give you a list of sections or a list of grouping that has been done to this data set. Within the Copernicus Sentinel datasets, this represents the Sentinel missions, Sentinel 1, 2, 3, 5P, and 6 in coming days. So these defined in here. We have Copernicus contributing missions. We have Copernicus service dataset, which are the CLIMS dataset, CAMS, which I mentioned earlier, and federated dataset. These are the dataset that are brought in from a different backend. In the morning, I also mentioned about a Belgian backend, which is Terrascope. So one of the data that is offered by Terrascope is Provavi data, Provavi Vegetatio, I guess. That's how you would identify it. So those kind of data are something you can already find in CDSE through federated endpoint. And there are complementary data set, there are DEM data set. And within Stack browser, we are trying to onboard all of this data set following the Stack standard, which is the latest or which is the emerging standard that we want to follow with the raster dataset, or with different features that we will be using. It can also progress with regards to models on defining a certain set of standards in order to use the dataset across different platforms. Actually, we might have a lot of expert in-house here of Stack, so I won't be going in depth with that. So that is with regards to data. Then we have different APIs. We have data workspace where you can request, okay, I want to download, these are the data set, I want to download in my computer. So that's also possible. You can download the data set in yours, put all this data set in data workspace. There is also a section for traceability to trace your data or the data you are interested in. So traceability is also publicly provided to everyone in here. Another thing that you can see at the bottom layer is Jupyter Lab, OpenEO, and Sentinel Hub. So these three are three different things, but they are still mentioned within analyzing part. With Jupyter Lab, what we wanted to mention was, like you do with Collab, if you have an account in CDSE, then you can use the Jupyter Lab of CDSE itself. It comes with direct access to dataset, but also it has this couple of folders which will guide you to using different APIs. OpenEO API and Sentinel Hub API. There could be a question on when should I use Sentinel Hub API and when should I shift to OpenEO API. If you are only interested in visualizing or performing very simple analysis such as NDVI computation, then feel free to use any of this API. You can go ahead with Sentinel Hub API as well. If you want to do much more advanced processing, you want to bring your own custom code, you want to bring your own data set, then it is recommended to use OpenEO API. In addition to that, OpenEO is fully open standard as in compared to Sentinel Hub API. So these are few factors based on which you can identify which API should I go forward with. In this case, I would say I won't be going to service immediately at the moment. I will go to that a bit later. But this is the page where you can find about the different services, data, what are the different features that's being launched this week, what is the recent news article about Copernicus data space, because you will find everything in this website. Today in this hands-on session, let's try to work around with OpenEO. And since I noticed that most of you haven't yet used OpenEO, so though this session is for advanced processing in OpenEO using the concept of user-defined function, I want to add a couple of cells at the beginning where we do simple analysis as well so that you get handy with how to load the data set or how to visualize the process or the built-in process that's offered in the ecosystem. So for that, you can do this in any preferred programming environment or even preferred client. So I think he mentioned web editor. So if you want to do the web editor, then that's in front of this URL, dataspace.copernicus.eu. Just add openeo dot the rest. Then you will land in the web editor page. But I'm going to present you with a programmatic approach using Python. So for that, I would request you under this analysis tab, go to Jupyter Lab. If you are not interested in using CDSE Jupyter Lab, then you can completely avoid this step. Otherwise, what you can do is you can just go to Jupyter Lab and it explains you about what are the features that it does, what are the detail, or what are the different flavors. By flavors, I mean they provide you with certain capacity to process the data online, to store the data online, what is the cluster that you want to work in. It gives different flavors. All these are documented in the Jupyter Lab documentation. But in here, I request you to click on Access Jupyter Lab. So while requesting for this training session, only requirement that I requested for the participant is to have a Copernicus Data Space Ecosystem account. Hopefully you have. If you don't have, then please feel free to go back to CDSE data space page and then you can log in and you will have the account. Does everyone? Yes, please. Does that follow OIDC? Yes. So I think that has a specific login that is done only for that service, isn't it? It does not follow the OIDC, which was also the OpenID Connect that was mentioned earlier. So yeah, if that is not there, then you can, because with OpenEO, we don't track user, we just follow the OIDC account. So these are the, open source ID Connect, OpenID Connect, so that would be required. Otherwise, you do need CDSE, and with CDSE, you can indeed log into different backend or even different provider. But in this case, since we wanted to use Jupyter Lab offered by CDSE, we do need CDSE account. And I will also be demonstrating on the backend of CDSE. So does everyone have here, or do you need time? Okay, can take your time in that case. I saw somebody nodding head, so yeah, please take few minutes to get your account in CDSE. All you have to do is go to login, go to your profile. For me, it will already pop up, but yeah, you can register in here. However, if you have the Copernicus browser login, then that should also already work here. For those who have already created an account and can access Jupyter Lab, I suggest you to go to this page. Here you can see Python, Julia, and R. These are the clients that's already supported by this environment, and so is by OpenEO. So you can use any method that you would like to do, but sorry, I have prepared only Python examples, so I will be sticking to the Python client environment or Python client approach. Give me a thumbs up when you are in this page. Okay, we have 1, 2, 3, 4. So out of the room, we have 4, 5. I think I would still need a few more thumbs up. So please take your time. Or you can say, I will skip this part. Just go ahead. I will just watch. That is thumbs up is also fine. Okay, I see a couple of more thumbs up with that. Though you are skipping this part, but I hope you are with me in following these steps. So when you land on this page, you not only see this different client or that you can execute or different environment that you can choose, you have these 2 folders. In My Stories, you can store all your files, all data set that you want to store, different computation analysis, or you will be doing, you can do it within the My Stories. It will stay there. However, if you create outside here or within sample, then when the server is shut down, then everything will go away and then we cannot retrieve. So it is recommended that when you create a notebook or a Python file, do it within this My Stories folder. It will stay like this. However, if you're inactive for, I think, 3 months, then you will receive a warning that should we remove these resources from yours if you are not using. So that will be there. But if you are using it or you are just logging it once, run one cell, then that's also fine. But here, what I wanted to show is the second folder. Is everybody with me? It's fine. This side, everyone? Okay, okay, okay. So in the samples folder, you will find this different folders which are representing the different API that we have. And here it is not all the examples that we have in OpenEO community example, but in here we brought very few examples or very few notebooks that could be helpful in onboarding you in using OpenEO. There is also Sentinel Hub API notebooks, which you can go, and as you can see, there is a lot of use cases that you can already use in your workflow. So that would be with Sentinel Hub API. There is also a geo package which try to summarize the latest the stack API that is in CDSE. It tries to use it. It tries to fetch the data set from different provider, and then it accordingly play around here. So these are different. And within OpenEO, you see very limited notebook as in compared to community example. I'm focusing a lot on community example in here because community example is by all the community, and we try to maintain feature there up to date. We try, there is a specific group who also try to maintain it here, but most of the features are documented in community example or shown there. And we didn't want it to have duplication of code. So we just stick to the community example. However, there is one notebook that could be interesting, and that is what I will be running in today's session. So you can go within here. There is this introduction to OpenEO. However, in here you will find a lot of text to describe you to go through different process. The use case would be same, but as I mentioned earlier, since many of you haven't used OpenEO yet, I wanted to add a couple of initial steps to get onboarded with. So I do have an updated notebook. I will also update it in this sample section immediately after this summer school. Otherwise, it will also be provided in the link where you will find all the materials. But if you want to go along with me, then for getting started step, I request you to follow what I do. For advanced use case, it is same what is done here. So should we start programming? That's fine with everyone? So far, yes, please. Yes, okay. You are here in this page. Okay, let me show which is the different page. You are here, your screen looks like this. And then you see two folders, My Storage and Samples. If you go within Samples, there is a folder called OpenEO. When you click on OpenEO, there is OpenEO Introduction. The others are also OpenEO Notebook, but today's notebook is this one, OpenEO Introduction. And when you select this, as you can see, OpenEO kernel is automatically selected for you. So that will have most of the feature that is required for OpenEO, being the OpenEO package itself. Okay. In my version of code, you will see a bit less text, hoping that you will hear me rather than reading the text. But indeed, text can be more descriptive than me, so please feel free to switch between any of the option you would prefer. So I think we already had a good discussion, or not discussion, I would say description about what is CDSE. After today, I hope when someone raises you question, what is CDSE, you would be able to answer that question. Is that fine? Then can I ask anyone in here, what is CDSE? Very simple answer is also fine. What do you think is CDSE so far based on what I have explained? So, okay, yes, that's already a plus point, indeed. It's a platform where you can file all the Copernicus data. Is it only data that we get there? Yes, indeed. And you were also about to say something? Add.
Well, that it's a very easy one-stop shop between all the different backends and
Yes.
extracting the data that you need. So
Yes, indeed. So we already had an answer on data, the tools and resources to use it, and an interesting part about the federated system that's supported by the CDSE. So this is what summarizes CDSE as a user-centric platform. So I don't think I need to go again with what was CDSE, but though we had a long conversation in the morning on why to use OpenEO, I really like this figure because when I was doing my master's, I'm a geomatics engineer, had to deal a lot with remote sensing data set, but no one introduced me with such an API. So what I used to do was this step. I just wanted to calculate, I just wanted to find how much greener my area was, or sometimes just see, okay, can I get a RGB image for the reason of Wageningen? So what I used to do previously is, where can I find this data? Okay, CDSE wasn't there. Or maybe, okay, there is something like CDSE. I need to create an account. I found something like Sentinel-2 data set. Okay, maybe that gives me RGB, but when I went into that platform, no, it just gave me other bands. So now do I go to another platform seeking for that data set and create the whole new method of logging in, whole new algorithm in my mind and everything? So that is something that I used to answer myself in the beginning. After finding the data, and in most of the case, it used to be, okay, in Google Earth Engine, you will find an easy way, just log in, fetch the data, you will get something in visualization. That was an easy. And as I was a student still, I would say I didn't care much about how much it would impact on my personal information or not, or if I will be logged in within a specific system or not. That was not a matter. For me, the answer was I just wanted RGB image, where it be. So, okay, I landed into that platform, but now it told me like, okay, you have these many different data set for a specific day in 2 days, this much data, and the cloud was different in different days. So I had to figure out all of those, then clip it according to my extent. Then only after downloading the whole data set, I think about, okay, finally the first step is done. Now I can sit down to think about what is the algorithm that I do. So this was the whole cycle that I used to follow when not having to use OpenEO. And that was not only part. When I wanted to, because in my master's, I had to move to data handling, which required vast amount of data set. So it was not only learning about remote sensing data set, but I also needed knowledge on high performance computing. And that took much more time rather than investing more time on the science behind the remote sensing data set itself. So if you are keen in understanding on how high performance computing work, how to handle data in the backend, then sure, that's also a nicer field to explore. You can do that with remote sensing data set, and it's very interesting. But for those who want to focus more on science and not to have much time invested on this, it could be quite tedious when you had to deal with a large amount of data set. So that is where I guess community realized that let's move to a cloud-based solution. Let's avoid the part of downloading the data set. At least that would already simplify the workflow. And that is where OpenEO also came into scene to provide a cloud solution, or we say cloud-based processing solution. And with OpenEO, this time we wanted to provide with a unified solution, not only access a specific backend that provides you with a specific data, but with the same method, you can access different backends. Initially, we used to also have Google Earth Engine as one of the backend, but you can still access Google Earth Engine where in the place where where we said openeo.dataspace.copernicus, you can say Google Earth Engine.com or something like that it was, but it depends upon the backend whether they provide services or not. So after a while, Google said, no, we are not providing open source services. So it is no more flexible backend available that you can connect with OpenEO, but that was one of the backend. So yeah, OpenEO wanted to act as one entry point to all this backend where you can do cloud processing. That was the idea. And while focusing on this part, actually, I had a very interesting conversation with one of my friends during lunch that these programming languages are developed for specific reasons. So Python was developed for a different reason. R was developed for a different. I agree to some extent, but for users who want to focus on analysis, I'm not sure if we want to rely on different cores of this language. We want to be flexible. Okay, I developed this in Python, so my friend who is using R should be able to run the same workflow using R. So that was the idea we wanted to focus with OpenEO. So you can use any preferred language. And I already mentioned this in the morning as well, that we very strongly support FAIR principle and open science. Open science in the sense that the data set that is promoted in OpenEO are open source. The algorithm that is developed, they are interpretable, and we highly encourage the concept of code reusability. So this section, I guess you will find a bit in the same slide, but you won't find a link to CubeSand Cloud MOOC. In this MOOC, you will have a detailed description. When you go to the Google and search CubeSand Cloud, you should find it there. I will also paste this in Mattermost. That's one thing. Actually, this MOOC, I pasted it here because it gives a detailed description of what is DataCube, what is open science, why we should support FAIR principle. All these things are described very well in this MOOC, including OpenEO. So I thought this would be very much useful even after your summer school. You can go back to it, learn the whole process, and learn additional factors about open science community, what is open source, how it's different from open science. And I think there was also a question on machine learning MOOC. So you can also find machine learning MOOC as well for remote sensing dataset in the same platform, which is EO College provided by the European Union. So that's there. And how to get started now using OpenEO. I'm not sure if you remember a figure that I showed today morning. There are only 4 steps. The first one, authenticate yourself or connect yourself to whichever backend you want to use. Second, identify the collection that you want to use and load it. Third, apply the algorithm. And finally, execute the process or say, please download the data set for me. So following that, I will run each cell myself so you can follow me. And I hope Net will support me as well as the platform. So in this kernel, Folium was not installed. So I installed Folium for my own visualization. You can skip that part. The main part that you would like to install is import OpenEO. So that's done. And this is, again, the figure that was shown from the morning that you can use all different clients. I didn't mention here Julia because it is very new to me as well. And we don't have a lot of examples in Julia that you can use. So with that, we will come back with a concrete example later. But at the moment, these example with these clients are already available and can be actively used in CDSE. So let's connect to the OpenEO backend. Before connecting to OpenEO backend, you can also see a bigger figure of OpenEO Federation. But before that, you can run this cell. Can you find this cell in your, do I need to increase the size or it's fine to the people in the back? Can you still see it? Okay. So if you are in that cell, then what's it said is like OpenEO instant, connect me to this specific backend. And here I'm already saying authenticate OIDC. If you only want to visualize what are the collection that this backend has to offer, what are the process that is already available within. You need not authenticate yourself, but if you want to download specific uh, data, or if you want to run an algorithm, then you do need to authenticate so that you specify where do you want the processing to happen. So here, as you could see, I provided a URL saying, connect me to openeo.dataspace.copernicus backend. For me, since I was already connected, it just said authenticated using refresh token. But for you, you might get a link. When you click on that link, it will direct you to CDSE, where you have to input your CDSE account. Were you able to do it? Okay, I can already see people nodding here. That's great. That's fine. Yeah, do you have? Okay, okay. So I think most of you are able to connect. Please raise your hand if there is any step that didn't run for you, okay? So before running any process, I wanted to quickly check what are its capabilities. I don't think this is helpful, but if you don't know what is available there, then you can always hit tab to see list of process that you can run. So in this case, actually, I wanted to just look what is the capabilities of this backend that I'm trying to connect. It gives me an URL, what was the version of this instance in this backend, OpenEO instance in this backend. It gives you the production information, what is supported functionalities, if there is any billing in place, and how is the currency, or when I do processing, how does it happen? And as you can see, it is saying buy credits. Not buy credit, using credits. So these credits are like when you register yourself in CDSE, you are provided with 10,000 free credits every month. And we have seen that it is quite enough to do research purpose. I will also show that at the end of the slide. But the main reason of placing the credit was for wise use of resources. That's the sole purpose, because we have lots of users out there in the globe using CDSE, and if we have also seen users using this environment for data mining, so we have seen misuse of such platforms. So I think this was a wise decision to in place certain amount of credits. But indeed, if you are working for an educational purpose, and if you run out of credits, saying that, okay, I was doing this research and this is what happened, can you please replenish? You come back to the support desk, and they will help you to update the credit as required. So you can see the capabilities in here. Actually, I wanted to also show you another backend, which I was saying, openeo.dataspace.copernicus.eu. And let me actually connect this to, assign this to a new variable so that I can show you a comparative view. I don't know. So in the next one, I authenticated myself with openeo.fed.copernicus.eu. In the federation, we at the moment have Belgian's Terrascope and CDSE. So we should be able to use both resources from CDSE or from Terrascope based on the data that we are requesting in when we connect to the OpenEO Federation backend. So this was what you saw with CDSE endpoint. Let's see what is the capabilities of the Federation endpoint. There is the link, the OpenEO version is the latest one. It is in production. So as you can see, these are the supported functionalities as in compared with the previous one. Same here, the billing mechanism is credited. And you can see one additional tab in here called Federation that shows what are the multiple services or multiple providers that we have at the moment in this one. So that was the case. Now let's move towards the part of loading the data set or using the data set. Yes, please. Web editor. No, actually, you cannot. It's like if you are doing, in OpenEO, we have, as I mentioned, two different processing, synchronous and batch job. For batch job, it depends upon, for example, your job took quite a while in queuing. So it is solely based on the resources that was used. and it is accordingly computed, so it will vary for sure. For synchronous job, we have a minimum amount of credit that is in place. So yes, for synchronous, you can specify, okay, this was the amount. But for batch job, it is based on the resources. But the good part is like when you have error, though it says, okay, this might credit was there. For the job that failed, it does not deduct any credits. Um, it- yeah, in that case, unfortunately, we cannot already specify because the algorithm will differ. And if you, yeah, if you have a benchmark saying that, okay, this much credit might be consumed for this much extent or this temporal extent, then maybe that's something we can look into. But indeed, at the moment, for batch job specific, we don't have such. Okay, now moving on to the second step, which is identifying what data I can load using OpenEO as a data queue. So for that, all you do is you say, list me the collection that's provided in this backend. As you can see, there are 20 collections from CDSE that you can access. Okay, or you can in your own laptop do connection.list collection, then this will pop up a list of collection that's available that you can access. And if I go to the federation endpoint, you can see there is 72 collections that you can access. And the one that's coming from federation is like this: Copernicus Global Land FAPAR product. So this you can directly use. You can find a descriptive information of what is this kind of data, its license, which is free. Most of the data sets that provided with OpenEO, as I mentioned earlier, is free. And you have an extent of where the data is. Similarly, the temporal extent for how long the data is. Another interesting data set that is the ESA World Serial Irrigation data set. This was from the previous version. You can find all this data set that was prepared previously within a specific project, which are already available in Terrascope, now also through your CDSE account. But in this case, I wanted to use Sentinel-2. So if I go a bit down and read the description, so we have Sentinel-2. This is the quick description. The license is proprietary. By proprietary is from ESA. You have the extent for the whole world. The temporal extent is since 2015. And provider is, as you can see here, you will find a list of name of who provided the data. So that will give you an idea of who maintains the data. In this case, CDSE is the maintainer of the data. If you go back to Federation and if you see who provided the data set of CGLS or Provavi, that would be different. And same would be for the maintainer of the data set. So these are a bunch of information you can already see about this data set. But it's like, I just wanted RGB. I don't want the whole tile. And neither do I know if like for today, if there was a data set. And for me, I just wanted a good image. So I don't want a cloud in that image. So what I just say is get me Sentinel-2 for the month of August. Since I was preparing the notebook a few days ago, I kept it 30. You can keep 30 first so that you get the data for the whole August. And in here, as you can see, I specified bounding box, but you can also bring in your feature collection. So it should not be only the bounding box while you work with. And it should not only be, I mean, it can be, but it's not restricted that it is only a single polygon. It can be multiple polygon as well. And here I say, get me RGB band from Sentinel-2 with a max cloud cover of 15%. Since this code is not there in the notebook that you might be looking, you can try if you want to. While you are typing that, let me quickly showcase what is the interesting process that we are using here. And that is one of the process that you will often use when working with OpenEO. That is load collection. So load collection is built-in process of OpenEO that helps you to load data from a specific backend. I think it is nice time to mention we also have load stack. So load stack is when you want to fetch a data set which is available as a stack somewhere else. For example, there is a stack collection available or provided by OpenGeoHub, and you want to use it in an OpenEO workflow, but it is not already there in CDSE, yet you want to use it in the CDSE backend. Then instead of load collection, simply use load stack and get the data set. Only requirement would be the stack collection follows the stack standard, and the latest standard is I think 1.1.0. So that should be up to date. And with OpenEO as well, we are up to date with that. So hopefully you should be able to load the data set using that method as well. So I assume you have, oh no, okay. It's okay, take your time. Meanwhile, is there anything so far that's still not clear or you are not convinced with? Not in this example. We do have in community example. Yeah. Do you want me to quickly show or someone is still looking? Okay. Yes, I recently prepared a community example with load stack. Oh, okay, sure. I think I will do that. But it's like not with the GeoHub's collection. It's with the planetary data collection. But indeed, it's the same one because, yeah, I was trying to use the collection offered by the team. But when I was doing that, there was a difference in the metadata, mainly with regards to, I think, temporal extent on how it should be defined. So I was not able to load it using Stack. But I know that the fix is already there. And I haven't tried it recently, but indeed, that's what we do. And that would be a very interesting use case to even come forward with, I would say, because in that way, we promote not only the open source API, but also open data set. So coming back to this one, so are you able to complete this? Okay, now we said we want Sentinel-2 data set for this specific reason and for only these 3 specific bands. Now we want to apply additional algorithm that might be there, built-in function that's already offered by OpenEO. So for that, as we did for list collection, what you can do is list process. When you say list process, it gives you a bunch of process that's supported by this backend. And when I say describe process, it describes that specific process. So in this case, you can already see I'm selecting a specific process called reduce dimension. The idea while preparing this notebook was, though I requested a data set for a month, I only wanted one image that I can keep it somewhere. So I just wanted to have the maximum value for each pixel in that whole month. For that one, I will have to reduce the dimension by time. So that's why I use this reduce dimension process. You will find the description on what does it do, what are the parameters that it expects, and what does it return back. As you can see, it is still a data cube. So we are still going on creating building blocks of processes. So I think I ran this step, right? Okay. That's there. And using the reduce dimension process, I give the dimension time and max reducer. So when I run this cell and try to visualize, then this is how my workflow look like. If you remember in the morning, I also mentioned about the JSON graph. This is how my JSON graph looks like, but indeed, I think you can use flat graph process. If you want to visualize it as in a JSON format, this you can copy either directly to a web editor or to a client saying convert this language to R and then you can get the code accordingly. But indeed, in here, I just wanted to show you how clean and easy way it is to visualize what am I doing so far. So as you can see, I just loaded the data, reduced the dimension by time. So by that, I do need to have only one image without any cloud, hopefully. And we already had this conversation of two different methods in OpenEO to execute the process, synchronous as well as batch. With synchronous method, it is recommended to use when you have very small extent that you want to process, or your algorithm is not very complex. Synchronous, like when running this method, this workflow, with synchronous method, it can host up to 5 minutes interval of running. After that, it will crash. So if your workflow is very long, then it is recommended to go ahead with batch job-based method. Additionally, with synchronous method, you have the limitation of having logs. So if you want to monitor what is going on in your whole workflow, if you want to debug the whole workflow, then indeed you have to use the batch job-based method. So in this case, I was just say download, then it should download the output for me. And as you can see, in this case, I'm saving it as a netcdf, but it could have been simple TIFF file. And in OpenEO, the TIFF file that you get are cloud optimized GeoTIFF. They also, having said that, they already include most of the information that's required to prepare a stack collection or stack item. With that, you can publish your own stack, host your own data warehouse or your own data center, which is, I think, not a recommended approach as we had discussed in the morning. But indeed, there could be some product that you prepared on your own and you want to use it in your workflow, which is not hosted anywhere in that manner. You can always publish it as a stack and reuse it back into the workflow. As you can see, it was completed. And when I load it using the standard X-array-based method, you see there is no time dimension in here. I just visualize the data set. This is, I guess this is where we are. At least this is the reason of Wageningen that I randomly chose. So let me know if we are somewhere within here. Otherwise, at least we are here.
Cannot download the data. There are some connection error.
Were you able to connect with the, did you authenticate yourself in the CDSE? Whenever you get such error, I always recommend to confirm yourself going to a platform called, okay, from DataSpace itself. Was the same case with anyone else who ran this workflow? Did anyone else run this workflow? Was it fine for you at least? Okay, so for you, what I would recommend is, in this platform, there should be there is a place that should be called as OpenEO Algorithm Plaza. Okay, I think I do need to go within here. Here. So you do need to go into this platform. This is how I landed in here is like when I went to the OpenEO page, in DataSpace, there is a link called OpenEO Algorithm Plaza. So when I click, I land in this page. Here you can monitor about your profile. And within, if you could log in here and confirm that you have enough credits, then it should be fine. If you don't see credits, that means your account was not properly set up. Because you just created and it's the beginning of the month, so I assume there should be credits. Everyone should have at least 1,000 credits here, plus 5,000 credits in the Terrascope as well, because Terrascope also provides you with 5,000 free credits. Were you able to see that? Okay. Okay, take your time in that case. Could you otherwise try connecting to the OpenEO Fed? You cannot. Why? Oh, I mean, what was the error?
Error.
Okay, that is weird. That should not be the case because you should also be able to have access to that one.
Oh.
Okay, while others are exploring, can I quickly go and check for him? Meanwhile, maybe I can share you where is the community example. In the Google, I would just, okay, for me, it already pops up, but I would suggest you to search community example OpenEO, and you will land into this page. And when you go into Python, you will have a bunch of examples within here. Meanwhile, I will quickly have a look at his workflow on what went wrong. Yeah, that could also be the case. But did anyone else also face the same issue? Are you as well? Yes. Yes. For others, I would recommend going to this GitHub page called Community Example and have a look at what could different use cases that could be done with OpenEO. I won't say that you would be able to identify each step or to run the whole thing, but what is possible using OpenEO as seen in the title itself.
I'm using my cell phone data. If I like
The network from here should also be fine. No, it is credit issue definitely. Yeah, and actually, I think you are also one of the users who has the yeah, I will repeat it maybe. No, that's kind of as was mentioned, the model is credit issue. Actually, this is the to the spot. Some accounts were not updated this month. Should not be the case. Okay, so I think that was fine. Meanwhile, okay, there was one user who also identified a bug, not exactly bug, I would say, but there was something that we encountered this week. By this week, I meant, as I mentioned, everyone's credit should be replenished each month. But we noticed that for the user who were registered after 2025, credit were not replenished for some reason. We are working on identifying the main cause, but if anyone here also is facing that issue, then please reach out to me. I will immediately update that credit because, yeah, you should get those credits. Having said that, let's go back to the notebook where we were working on fetching the Sentinel-2 dataset. So that was a simple use case that we tried on. Now let's move to an advanced use case. So for advanced example, what I wanted to show you was, let's count the heat wave days in Netherlands. You have an example in here as well. You have the example also in samples, but there is also a folder called heat wave in this community example. It's the same as you have in samples. So if I go back, it is summarizing what was in the before part. Now with OpenEO, we are doing in just few steps of just mentioning the data without downloading it and then specifying the extent. No need to go to a completely another step to clip the data set in order to apply your algorithm. So this all will be done in just few steps here. So in this case, if you are in the sample folder, you will have access to this Netherlands polygon that I used. And I'm using this time a GeoJSON feature collection, a single polygon. So as you saw, I was using this Folium package. So if you didn't run this pip install and you are still using OpenEO kernel, then it might say, please install that in a very harsh way, but do install Folium package if that error pops up. So we are trying to process heat wave. For that, we are using Sentinel-3 land surface temperature layer. And this, as you can see, we are, in this case, I'm loading two separate data cubes. One is with the band land surface temperature itself, and the another is the confidence interval, which I wanted to use in order to mask out the land surface temperature layer. So in this step, I specify what is the date I want to use. And instead of doing special extent is equals to AOI, I'm doing filter special. Okay, I do need to restart, but I hope you all are there with me in that case. Okay, so it looks like, Janet, to reload the server. Okay. So while that's taking time, I was talking about in the cell, as you could see, we could already specify special extent is equals to AOI, but instead I chose to use a process called filter special .aoi. The difference between these two is already documented. However, I wanted to mention it here. So when I just specify within the load collection feature, it gives me data in covering that bounding box, not only in that specific AOI, but covering the whole AOI as a bounding box. But when I do filter AOI, it specifies the output only within the specific AOI or the region. Is someone else notebook also still loading, or is that the case with everyone? So are you back? Because it seems like for me, it's back again. For you, it's still taking time? Okay, well, while that is still loading, maybe I can go back to the original example or where the notebook is so that you follow what am I saying. So you can find this notebook here again in the community example. But since mine's running, I quickly run this. So yeah, I was saying about this part. So in here, I specify separately at filter special so that my data is clipped over this AOI. That's the only reason. Otherwise, you can use any method. So here, I load two data cube. Now I say, I want to mask my land surface temperature based on this confidence interval using the mask functions that's already available in OpenEO. And as you can see, I'm also doing aggregate temporal period. We can look into what does this aggregate temporal period does by saying describe this process. So basically, what am I trying to do in this case is, as we know in Sentinel-3, we can get data, multiple data set in a single day, or there could be data set over an interval. But I want to have a consistent data set. So I say, get me data set on a daily basis. So it just interpolates the data set and gives me data on a daily basis if there is no data, or if there is two data set, then it tries to give me only one data set based on the reducer that I specify. So that is what I'm trying to do using this function in here. So far, what we have seen is, okay, there were a bunch of functions that OpenEO already provided, and that was useful. I will be using those. It was good. But now what I wanted to do was, I wanted to apply condition. And OpenEO didn't already have a built-in function, but I knew with Python, I could just say, is this condition true? Is this condition true? And I want this, both of this condition true or not true. So I just had this simple concept in mind, which works in Python, but it is not yet implemented in OpenEO. So what I do is I call something called user-defined function in my workflow. This is a very simple case that I'm demonstrating here, but user-defined function can be a very complex example, or even, yeah, it can be as simple as this. And as you see in here, I'm writing everything in an inline string, but indeed an ideal way to write a Python function is in a Python page, and you can do that. For this purpose, I just wrote it in here. Otherwise, we write it in a separate Python file, whichever you feel comfortable with. So the main idea of user-defined function is, as I mentioned earlier, to bring your own code so that you can do wide range of application, or you can do wide range of researches. And this Python code are based mostly on X-array data array objects. We can also pass contextual information based on the requirement of the UDF, or you can just simply do as we did in here without any contextual information. So what am I doing here is, since I'm trying to test in Netherlands, so what I've learned is, like, Netherlands has this condition that if a temperature goes above 295 Kelvin for at least 5 days, and also if the temperature stays between 295 to 300 for at least 3 days, then only it considers it as a heat wave. So this is the two conditions that I wanted to apply. So as you can see, what I did within my X-array is I said, okay, first condition is it should be greater than 295 for 5 days at least. And in the second condition, okay, it is fine for it should be greater than 300 for 5 days, but also it should not be less than 295 for at least 3 days. So these are the two conditions that must satisfy in order to be a heat wave. And I simply apply the AND condition. This was a simple Python function that was injected in here that now I wanted to apply over my whole data cube. One thing to remember when we want to implement anything in data cube is it comes also with a risk. By risk, I mean when you define everything with OpenEO built-in process and then it takes care about data parallelization and data handling. But when it comes to user-defined function, OpenEO cannot look into, okay, what was going on. So you do have to be careful on how efficient your code is within the UDF itself. And when you have UDF, yes, please.
Just to ask a short question about the UDF. So I see we are importing the Python library again. So assuming, like, when you are using user-defined function, we are getting to a new Python environment.
We are using the Python that's already installed there, yes. But indeed, there could be some package that are not there. So that you would have to paste it as an inline string within the UDF.
I see, the pip install.
No, there is another command saying that these are the UDF dependencies.
I see.
I want this within my package.
Yeah.
Okay. And another way also is like these are when the packages are already available in pip. You can define as a user dependencies or UDF dependencies. But there could be cases like you developed your own package and it is not available as a pip. So what you can do is you can create a dependency file, and then you can pass it when you execute the process. You can say, this is the user dependency file. This will be required while running my user-defined function. So pass this as a UDF. I can show you a couple of examples at the end of the presentation. So while that's been there, I was coming to this part where big image about cubes and how user-defined functions can be used within OpenEO. So actually, these are 4 main processes that's there in OpenEO. Whenever you want to implement a UDF, you will be using one of this. But it depends what is the condition, or it depends what is the requirement of your use case. If your use case says, okay, I just want to apply over all my data cube, both in X, Y, time dimension, then I simply say, pass the UDF and just apply it all over my data cube. But if I want to apply it to my dimension and still want to preserve some dimension, whether it be band dimension or be temporal dimension, then I say apply dimension. Then there is the other one called reduce dimension, which I say, okay, apply it along this dimension, but then after that, reduce that dimension. So this could be handy, especially when we are calculating maybe time series. Then we have apply neighborhood, which basically considers pixel in its neighborhood. So that's the main idea of to choose which is kind of useful in my use case. So this could differ. And in my use case, I had UDF. I just said, I want to use apply dimension because I want to apply it to all my data cube along the time dimension. But still, in this case, I'm preserving the time because in next step, I want to calculate whether the heat wave days condition was satisfied or not. If it was satisfied, how many times it was satisfied. So for that one, I just say sum up all the days and reduce that time dimension. So if I print out how the workflow looked like, okay, I think I didn't run along with you. So So this is how the process graph or the process so far looks like. We load 2 separate data cube. We applied filter special. We did apply some function to it. We did masking. This greater than function is when we consider the confidence interval value of how much it should be. And then we applied the aggregate temporal period followed by the UDF. So this is all you can monitor when you go on creating the workflow. So now we came to the final part where we want to run the workflow. And as you can see here, I have specified something called job option. If you don't want to have this concept, you can completely avoid it, but sometimes it is very much useful. So you can specify these different parameters or different flags. So in this case, since I'm processing all over Netherlands, so I thought the resources that will already be available by default might not be enough. So I want to increase the resources. So I said, take my executor memory as this much, Python memory as this much, and you can find all this information on what are the different flags that the job option have in the documentation itself. But these 3 are kind of interesting for me. Also, I wanted to study behavior, so I just say, okay, these, can you please increase this? So I have specified this job option. And if you remember in the earlier step, we just said .download and then got the output as netcdf. So in this case, I'm passing it as a batch job. So I'm saying execute batch job. There are a lot of ways to execute a batch job, but this is something that I really prefer because then it gives me job ID that is running, and then it gives me a progress of how much it went. And also I can specify my job option in here. The dependency thing that I was mentioning earlier is like, okay, if it is not a pip package that you can specify within your UDF, you have to pass a separate file, then you can specify within the job option itself. It has a flag called user dependency. So you can directly pass in within there. So let's run this workflow. I will just change the name. And while it's running, there comes the concept of web editor. So I would like to now move to web editor while it's running, because there also we can monitor the job. So what I just did to move to the web editor was, you remember this endpoint that we used at the beginning to authenticate ourselves, openeo.dataspace.copernicus.eu. So we just paste that to a different browser. So as you can see, my job is created, then it will go to queuing stage, and then it will start running. So it does everything on its own, or whether it needs to be parallelized, how does it handle? So that will be there. So I was going to web editor. This is how the view looks like in web editor. When I log in, then it asks me, okay, it is CDSE credential that you want to log in, because I'm logging into the specific backend. So I do have, and I just log in here. And you can see there is this job created that I can also monitor in here. I can request to show me detail of what's happening. Okay, it's already started running. This was the job ID that's there. This is the workflow that's running. And so far, it does not give me additional information of what's going on or how much resources was consumed. So we will have that once the job is finished. But what I wanted to show you here is, okay, if I just click in here, I get the whole process graph that was created earlier. If you want a JSON representation, then that's here. And I think I saw Tom's comment yesterday in Matrimos about awesome spectral indices. So with that, I assume there are users who are interested in using that package. So an easy way of using such is, like in this web editor, what you can do is just click on widget. Okay, I will clear this up. Yes. And I want to go to wizard. There is compute spectral indices. So this is already integrated or installed in OpenEO. You can directly use. So you just specify which is the collection you are interested and which was the indices that you wanted to calculate among here. So this is something that you can easily do in web editor. You can also do it in programmatic way, but that was an easy, quick fix that you can do in here. What you can also monitor in a web editor is the collection that we discussed earlier, the processes that is supported by this specific backend. In my case, I guess you will see much more than in yours, because this not only showcase the process that is built in OpenEO, but also some process that I built in myself for my own use. So that is, for example, if I say, okay, there is one process which a weird name. So what I did was, I want to load Sentinel-1 collection, Sentinel-2 collection, and just merge it and give it to me. I just saved it as a process so that I don't have to redo the whole step again. I just come back here, I provide special extent, temporal extent, and I get the result as I want. So those kind of things, you can save it in it. So that's why you see much more number than yours. Additional thing you can find is the UDF runtime, in this case Python here. And I wanted to show you an interesting feature that has been recently added, and that's jar. So with OpenEO, we now support saving your output as jar file. You can also read the jar file, but this feature is also already integrated. So this is another standard that we are following up. We're catching up with that. So while that's still running, it still shows here as well, it's running. I can show you how it would look like when the job finishes. So this was one of my job that ran a while ago. So once finished, it will show me how much credit did it consume, the whole workflow. And it will show why did it consume 4 credits. That is this usage matrix. It will show how much CPU usage was done, how much wall time it was, input pixel, max executed memory that was used in this process, and memory usage and other information. So if you say, how do I calculate based on this matrix my credit? So this is also documented in the OpenEO documentation, but it is based on the standard calculation of credits thing. I think that's also something I will provide you in the Matrimos on calculating why did it consume that much credit. So these information, you can find it in here. So as you can see, the job finish, I can directly download it here, or you can also copy this URL and go back to, if you want to work now in QGIS, then go back to QGIS. And in loading raster layer, you can say, okay, there I have HTTPS link. I just want to paste this. Then you will get your data there. However, okay, it is taking time to show here. I want to plot it in here itself. So let's wait for a bit more. Okay. So that's finished. And let me visualize my output, how it looked like. I might not be scientifically very much correct. So in there, I would like to invite you, if you have much better algorithm than just applying this two condition, for sure you will have, please feel free to come back in this notebook, or you can create your own notebook and also create a pull request to this repository saying, okay, I have a better heat wave notebook that could be useful for you. That is always welcome. But indeed, it can be a much more advanced process than what's only done here. I just wanted to show you a simple way of using user-defined function. But if we load how the data set looks like, so it should have plotted as it was before. Did I plot wrong? Okay, so it seems like I missed something. Oh, I guess I changed some visualization. So yeah. Let me see if my previous result was still fine. Okay, it seems like I might have changed something, but this is the output that I got previously, and this is what you should get as well. Otherwise, there should be something wrong going on. So this is how it looked like. That was in 2023, I guess, that we specified the date for. No. Oh, it was for July of this month. So July of this month, it looked like this in Netherlands. So it was quite hot in here, then I can measure. So that is something, but a bit moving ahead, when discussing about credits, can anyone guess how much this process might have cost us? Random guess. You have 10,000 credits. So out of that, okay. That was my previous job. Now because it's like, yeah, it took time to queue and everything. Okay, 100 was one answer. Somebody already looked into the answer into 9. So indeed, if I run this one, then this time it took me much less. That is 5 credit, because this time, I guess the process was completed a bit earlier. It was just completed in 5 minutes, whereas in my previous job, it took me around 8 to 9 minutes. So yes, it consumed me 5 credit while running this workflow. I have 10,000 credit, which will be replenished each month. So hopefully we will be able to do a lot of research with that credit. While saying that, I want to come back to the code reusability concept. This was an interesting use case, I hope, for you as well, to calculate heat wave. But if someone wants to replicate it for their own country or for a different reason, then would you prefer going to each cell by cell and running it? Or would you prefer just passing it temporal extent and this special extent and just say, get me the data set? No one would prefer anything? Which kind of method would you prefer? You would prefer the whole running of this, or?
Well, I think it's essential to have the notebook to know what's happening.
Yes, indeed.
But being to export it to a Python script and then run the Python script is
Yes.
faster.
That's true. So it's like, because I have a different audience in here, I would say they would still prefer to know what is going on each step. And that's kind of nice as well. And this was a very simple example. So indeed, you won't mind in running in the whole of this notebook. But there could be cases, for example, in World Serial, where they use large volume of data set from CDSE and use the trained model in order to not just calculate the feature, but also to get the final output of crop plan. For you, you can be limited with regards to the resources on processing such large volume of data set. So in that case, I guess you would prefer just special extent so that you can do further study on it. So these are two different ways of looking into. Yes, one way is definitely we can do code reusability by simply sharing the notebook. Another is publishing this as a user-defined process. And in user-defined process, only thing that will vary in here is, instead of passing a fixed special extent and temporal extent, I will just call it as a JSON parameter. So there is a parameter feature defined by JSON specification. So we will just define special extent as a special extent parameter, temporal extent as date and time parameter, and then just pass it into the workflow. Then this all will be defined as a user-defined process, which you can share within your team and then use. An example that I would like to show is going back to a platform called OpenEO Algorithm Plaza. And one work that I'm actively working on is this CropSat 2D, which provides you with cloud-free biopar products, but in a pixel environment. In a pixelated way. So here, what you can get is you can get NDVI, FAPAR, and FCover. The algorithm behind is quite complex, and I think you can find a detailed description of what was done within this in this blog post in this space. However, there are a bunch of users who are interested in understanding how the crop was like in this time and how it will be in few days, and then integrating this into their workflow as an input feature. So this is something that could be interesting, and this is where you can also showcase your own work. For example, you develop a very nice algorithm, but you don't want to share the entire code. You just want to share this much code to the larger audience. Then you can directly come here and paste it in here, the algorithm, paste it in here, the user-defined process, which includes mainly the ID and namespace in order to identify. So here I'm passing in a simple example, what it would look like. As we said, it would be importing OpenEO, authenticate yourself where you want to connect, specify special extent and temporal extent. And in this one, additional context that it takes is which kind of biopar you want to calculate. Apart from that, we just pass in, okay, this is the ID, this is the namespace, and when we run it, passing the user-defined user dependency that I was talking about earlier. So what does this dependency include is it's well-trained model. The model that was trained to predict FAPAR, FCover, and DVI based on the Sentinel-1 and Sentinel input are stored in this location. However, it will also need to fetch that model, and now it is passing it as a dependency. So if I run this, then I will get FAPAR, FCover, or NDVI with a 5-day interval. And this has proven to be very useful to several end users. If I have to namely say that, then PepsiCo is widely using one of this, where they want to identify the potato fields. So this could also be an interesting use case that you can use as an input feature for your workflow. But this is an example I wanted to provide to this audience, saying that your workflow could also be very much interesting to showcase here, as it will reach out to all the Copernicus data space users all around the globe. And with that, I think we can contribute to the part of using sustainable resources, because we minimize the code duplicacy. That was what I wanted to show in here. And you can find the credit information in here. Don't get shocked that, okay, if she has more credit than I have, I'm also a user like you, so I should also have 10,000 credit. But since I was doing quite some workflow, so I requested the team, can I have? So in similar manner, you can also come back and say, okay, this is the research that I'm doing, and can I have additional credit? However, tomorrow, if you come and say, okay, I need 200,000 of credit, then that must go through a circle of discussion on why are you using such resources. As you could see, it only costs us 5 credit to process for entire Netherlands. So you should have an answer for such a large amount of credit. That being said, I think I still have plenty of time. So far, yes, please. You can already ask me a question, because now I want to move even to a advanced use case side, but not running on my own, showing you in the community example on what could be done. But before that, so far, I don't know how it went for you. Were you able to grasp on what is OpenEO and how you can get started using OpenEO? We went a bit far until user-defined function, and I also mentioned you about user-defined process. So we went already quite ahead, and it is a lot of information. So I can imagine there could be some questions. So please feel free before I jump into the other part.